The best way to discuss analysis of variance is to provide an example. So imagine I have a sample of employees under normal times and I want to measure their level of stress, and I have 5 people in my sample. Then I do another sample after announced layoffs, and then finally a third sample during layoffs. I have the same 5 people in each sample, and I want to measure the impact of the announced layoffs. And that's what analysis of variance does. It allows you to compare different samples at different points in times. In this video, I'm going to make several calculations, all around the variance, also known as sum of squares. And I'll do this for all 3 samples: the green, red, and blue samples. And this is called sum of squares within groups. Now the next calculation I'll make is looking at the variance between groups. And I'll take its sum of squares, and this is known as sum of squares between groups. And I'll also take all these 3 samples and I'll treat it as one large sample or one large study. And this is called total sum of squares. I will compute an F ratio and see if it falls within the rejection region or not. If the F ratio is in this area, I reject the null hypothesis, and if it falls in this area, I fail to reject the null hypothesis. In the end, I'm going to make these 3 calculations, and combined with the degrees of freedom, I'll know the F ratio. Then I'll look up the critical value in a table, and I'll determine whether to accept or reject the null hypothesis. I also have a whole video on how to do these same calculations using Microsoft Excel. Total sum of squares is equal to sum of squares between groups plus sum of squares within groups. This is my first calculation I'm going to make now. To do this, I calculate the mean of each of the samples, the green, red, and blue means. Then I take each individual observation, so I take 2 minus 4, again that 4 is the mean. I take 3 minus 4, 3 minus 4, 7 minus 4, and then I'll just put the rest of them in. This is equal to -2, 3 minus 4 is equal to -1, 7 minus 4 is equal to 3, 2 minus 4 is equal to -2, and 6 minus 4 is equal to 2. So now I take -2 and square it, which is equal to 4. -1 squared is equal to 1. 3 squared is 9. -2 squared is 4. And 2 squared is 4. Now I sum all these up, and the sum is equal to 22. So here's what I did. I took the observation, each observation, and I took the difference between the observation and the mean. Then I squared it. Then I took all these values, which is sigma, or sum up. I summed up all the values. And I sum them all up, and that's 22. Now I'll repeat this for each of the different samples, but I'm not going to go through the calculations, but I'll show them to you here. The sum of squares within groups is equal to the sum of squares of each of the individual groups. So I take 22 plus 18 plus 14, and this is equal to 54. In your textbooks, you'll see this as SSW as an abbreviation. So I have one piece of the 3 sums of squares done, which is 54. And now I'm going to calculate total sum of squares. So I take all three samples, the green, red, and blue samples, and I treat it as one sample. And I also calculate the variance from the mean and calculate its total sum of squares. I take all these observations, and what I do is I calculate the mean for all of them, and it turns out to be 8.3. Now I take the individual observation minus the mean, so I have 2 minus 8.3, 3 minus 8.3, and I'll just fill in all the other values, and you get the picture. 2 minus 8.3 is equal to negative 6.3. So I have the observation minus the mean for all the values. Now I take negative 6.3 and I square it. So I take the observation minus the mean and I square it. And this is equal to 40.1. Negative 5.3 squared is equal to 28.4. Negative 1.3 squared is 1.8. And I'll just fill in the rest of the values. Now I take all these values and sum them up. So this equals 257.3. This is total sum of squares, or SST, and this is equal to 257.3. Now I have total sum of squares, which is 257. Now I'm going to calculate sum of squares between groups. So now, since I have two of the values, I could use algebra to calculate the third one, but I'm going to go through all the steps and show you how. Now I have all the calculated means for each of these. So the first thing I do is I take the mean of the sample minus the mean of the group, or all the samples combined, and I do that for each sample. Then on step 2, I'm going to take the mean minus the mean. I'm going to square it for each of these. And I'm going to show you this before I use the numbers so you can kind of follow along a little bit better. And finally, I'm going to add all these together. And you're probably stoked about doing that. Probably not. And then I multiply all this times 5. There. Let's do the numbers. The mean of the group was 8.3. The mean of the green sample is 4. So I have 4 minus 8.3, which is equal to negative 4.3. Then I have 8 minus 8.3, which is equal to negative 0.3. And finally I have 13 minus 8.3, which is equal to 4.7. Now I square each of these values. And now I add them all together. 18.8 plus 0.1 plus 21.8. This is equal to 40.7 times 5. And 5 is the number of observations in my sample. That's where the 5 comes from. And this is equal to 203.3. Yes, there are a lot of calculations, so hang in there because you want to pass statistics. So now I have all the values that I started out with, and this is what it looks like. So I have total sum of squares, which is all the samples treated as one large group. And this is equal to the sum of squares between groups plus the sum of squares within groups. If I calculate two of these, I can always calculate the third algebraically. Now we're into the final calculations. I take the sum of squares between groups divided by the degrees of freedom, which is equal to 203.3 divided by the degrees of freedom, which is groups minus 1. So I have 1, 2, 3 groups. So I have 3 minus 1, and that's equal to 2. And this is equal to 101.667. Now I take sum of squares within groups divided by its degrees of freedom, which is equal to 54 divided by degrees of freedom. And its degrees of freedom is observations minus groups. So I have a total of 15 observations minus 3 groups. So its degrees of freedom is 12. So I have 54 divided by 12. And this is equal to 4.5. Now I take the ratio, which is F is equal to 101.667 divided by 4.5, which is equal to 22.59, and this is my F score, my F ratio. Finally. But I'm not done. Now I need to look this up in a table, so I need to know my degrees of freedom for my numerator, which is part of the ratio for the top part of the equation of the ratio right there, the numerator. And I need my degrees of freedom for my denominator, which is part of the bottom part of, or the denominator of the ratio. You often see the F test or F scores written as this way. So F2, where that 2 is the degrees of freedom of the numerator, comma, 12, and that's the degrees of the denominator, degrees of freedom of the denominator. This is equal to the actual F ratio, which is 22.59, which we calculated. And also you'll see a little comma, P is less than 0.05, and that's your level of significance. So now we take this and we look it up in a table. We have degrees of freedom of the numerator on the top and degrees of freedom of the denominator on the vertical axis right there. So I take the 2, so that 2 right there, and I go straight down. Then I take row 12, which is that 12 right there, go down to row 12, go across, and where they intersect is my critical value, and in this case it's 3.89. So my critical value is equal to 3.89. And my F, remember, is equal to 22.59. So I draw on my little curve, a little distribution. And I draw my critical value, and I put a little red line there. Everything to the left is green. Everything to the right is in my rejection area. So obviously 22.59 falls into the rejection area, so I reject my null hypothesis. The next video in this series is on how to do the same calculations using Microsoft Excel. And please share the knowledge, share the love, Facebook, Google+, and Twitter. Like us, comments and questions below. Don't forget to subscribe. I'm always posting